Now we're starting to take a look at vector operations. So we'll be adding, subtracting, and multiplying vectors by a scalar. So we'll change the length of the vector. Starting off with scalar multiplication, you just multiply each value in the vector that's in component form by the scalar multiple. For vector addition, you add the x values together and add the y values together. And for vector subtraction, you subtract the x values and subtract the y values. Vector addition is pretty straightforward when you sketch it. You start at the initial point of the first vector and you go towards the tail of the second vector. But for vector subtraction, it's not as straightforward. You actually start at the tail of the second vector and go towards the tail of the first vector. This is just a list of some properties of vector addition and subtraction and scalar multiplication. They're pretty much the same as the properties of regular numbers, so I'm not going to spend too much time on these. Example 1, we'll perform some operations and find the component form and sketch our graph. So we're just looking for the scalar multiple of v, so we don't even need our w vector at this point. So 2 times the v vector would be multiplying our x value by 2 and multiplying our y value by 2. Sketching both vectors in standard position, vector v would be -2 and up 5. Vector 2v is -4 and up 10. So you can see the 2v vector lands on top of the v vector. They head in the same direction. It's simply twice as long. This time we're going to be subtracting vectors. Finding the actual vector is pretty straightforward. So we have w minus v, so we take our x values and subtract them, and our y values and subtract them. Make sure you go in the correct order. So this would give us a component form of 5, -1. I'm going to sketch all 3 vectors for you so you can see how they relate to one another. So we'll do our v vector in red. -2, 5 is that same vector we started with on the first one. The w vector I'll sketch in green, 3, 4. I'm going to graph w minus v using these 2 vectors as opposed to standard form. So we will start at v and head towards w, the tail of both of them. You can see that our blue vector, the subtraction vector, is heading right 5 and down 1, just like the component form. So make sure you understand you're starting at the tail of the one you are subtracting and heading towards the tail of the first vector. Some more operations. So we will, of course, perform our multiplication before we perform addition, just like regular numbers. So 2w would give us 6, 8. And then we'll add on that v vector for a total of 4, 13. Again, I'm going to sketch all 3 vectors. So v is -2, 5. We'll stick with v as a red vector. We'll stick with w as a green vector, but I'm also going to sketch 2w instead of just w. For vector addition, we have to put the vectors end to end. So where I stopped for our v vector, I have to start for my 2w vector. So I'm going to go 6, 8. I'm going to sketch the 2w vector from where I stopped on my v vector. Because we can add in any order, it's okay that I sketched v before I'm sketching my 2w. So I'm going to go 6, 8 from this new starting point. It won't be in standard position. And this one doesn't quite fit on the graph. But then the addition of the 2 is from the starting point of my red vector to the ending point of my green vector. So you can see we're going right 4 and up 13. Here's a you try question for you. Please come to class prepared to start this one together.